Okay, this is the first of the level 6 to 8 paper questions. So, new video. The graph shows the height of 150 fir trees. The table shows the price of the trees at different heights. Use the information to calculate the total price of 150 fir trees. Show all your working. So what I need to do is I actually need to say how many trees there are in each height range. So between 1.2 and 1.5 means I read up to here. That's the first group. And that looks like it is 4 marks out of 5, so it looks like there's 20 trees in that one. That's the easy one. I now need to remember that 20, so that when I go up to 175, which is this mark here, I need to remember that I only want to do above 20. So this adds, as with a cumulative frequency, this point is the number of trees less than 1.55. This is the number of trees less than 1.6. This is the number of trees less than 1.75, and that looks like it's 124. 120 there, and 20 here. So that's 100. So I'm now at 120, going up to the top, which is the 150. That says there are 30 trees. So the total of this is 150. I've worked out those parts. Now the cost for these trees, so the total cost is 20 times 18. Where are you? And turn it on. So 20 times £18 plus 100 times 22 plus 30 times 26. And the total of that is 3,340. I should show that for my working, I'm going to multiply each of these to give me my total going through. And it's even nicer if I can show 360 from the first one, 2,200 from the second, and the third one is going to be, got your calculator, so what it's here for, 30 times 26, and that's 780. And if I add all of those up, it's my 3,340. So moving on, question 19. Each side of a square is increased by 10%. What percentage is the area increased? So if I actually consider a square that's 100 by 100, that means its area is 10,000 units, so that's centimetres squared. If I increase it by 10%, so increase by 10%, that means add 10% to it. 10% of 100 is 10, so we're now doing a square 110 by 110, slightly bigger. Calculate the area of that one. 110 times 110, and that gives me 12,010. And so if I want to out as a percentage increase, the percentage out of 100 is the end amount divided by the original, the 10,000. I know what this is going to be. It's going to be 1.21. Divide that by 10,000 and multiply by 100 to turn it into a percentage. And And that gives me 121%. So that's not the increase, that is the area as a percentage of that one. The increase is 21%. This is one of those start change ends in a funny way. So we've got percentage 100. I need to do the area. Starting was 10,000 and 121, and I want to know what that is. So what I did was I did the calculation to calculate what the missing percentage was at the end, 121%, and therefore calculation in between, the change was a 21% increase. So it's a 21% increase. The length of a rectangle is increased by 20%, and the width is decreased by 20%. So we can start off with a square in the same way. So we're using the same square, and that's 10,000 as an area. Just using a concrete example that's easy to work with. Length increased by 20, so that's 120. Width decreased by 20, it's 80%. So now calculate the new area for that one using my calculator. 120 times 80. And that's 9,600. So therefore, do the same thing, percentage, 100 is again start change end. Percentages, we start with 100, I want to know what this change is. I'm going to work out that along the way, or I could even do the minus 400 in here. So it's 10,000 minus 400 gives me 9,600, and that's the area. So now I can calculate this change using the minus 400. So P equals, I think it's minus 4%. 400 divided by 10,000 multiplied by 100. And that gives me a 4% decrease. 4% original. I can work it out in the same way by doing this end amount as well. So I could do percentage at the end is 9,600 divided by 10,000. Take the 100 to the other side by multiplying by it. And this would turn around and say I have 96%. And 96% is a decrease of 4% again. Number 20, here are some sketches. Which graph matches the relationship below? So the circumference of a circle plotted against its diameter. We know the circumference is pi times d. That means that as the d goes up, the c goes up in a linear fashion. Each of these possible, and this is the only one that's going up in a linear fashion, so that's graph D. It goes up proportional to the diameter at the same rate. The area of the circle plotted against its area, so C equals pi r squared. That means it was, A equals pi r squared. That means it's going up as a quadratic, so we have to know what a quadratic looks like, and it starts with 0 radius, 0 area, which is that one. Or that one. As it increases, it just keeps getting bigger, 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 bigger. This one goes to a point and then starts going down. This is a quadratic, but it's inverted and it's got a funny offset, so this is graph C. The length of a rectangle area plotted against its width. So if a length times a width is equal to 30, the length is equal to 30 over W. This is a reciprocal curve. It turns these into fractions, so the bigger the number, the smaller it gets. The smaller the number, the bigger. So this starts off small, small, not what I want. Small width gives me a long length, and then as we get bigger and bigger widths, the lengths get smaller and smaller. This one is increasing again, this is increasing. This one is decreasing, but it limits. It doesn't keep going. You can keep chopping down the area of this, the width of this rectangle. You could actually make it a width of 0.5 centimetre. The length goes to 60. 1/10 of a centimetre. This goes up to 300. So it keeps going off a long way to the right. So that one was B, I think. Yeah, B. And moving on, this one is a trigonometry question. You may not have seen trigonometry in most of your lessons. If you have picked it up though, the trick is to relabel this triangle based upon it being a right angle triangle. Right angle is opposite a hypotenuse, so I'm writing my own letters. The 52 degrees has an opposite side, and next to this is an adjacent side, adjacent meaning next to. I don't know anything about O, so that's not involved in my problem. So this angle theta, remember the short phrase so ka toa, this reminds me of the ratios. We have an AH, that goes with the function C in the middle, and that's cos. So cos of my angle 52 degrees is equal to the adjacent, W, divided by the hypotenuse, which is 28. All of these, remember, it's an angle in theta, opposite, adjacent over hypotenuse. So you get these rearrangement formulae. And if I want to work out this adjacent side, the W, I'm going to wind up multiplying them and multiply by 28. So now I need to put this into my calculator. So cos function, turn it back on. Cos of angle 52, make sure you're using degrees, a little d up here, 52 degrees, multiply it by 28. So I take that cosine angle, multiply it by 28, and it will give me the length as 17.2. I'm only going to do 0.2 because we're talking about centimetres. The logical unit to go down to is the next thing I can measure, which is in millimetres. It could be worth writing up here a few more digits, 0.238. Okay, but the only digit I'm going to is millimetres as the next unit. It's worth measuring to that unit. Calculate the size of an angle X, so get the same SOHCAHTOA toa. Here's my H, O, A. If I look at those, I'm not using H, so I've got O and A. This is the toa, so tan of the angle X is equal to opposite over adjacent. So X is the tan minus 1. The inverse tangent. This is one of those where you can't just drag it and put it divide. It's the opposite function of 42 over 60. So now I'm doing inverse tan, so shift tan, and then inside I need to do a calculation. That's why I'm going to put it inside a bracket and close the bracket off. That wasn't a bracket, that's the bracket. First equals, and it says 39.99 degrees. 34.99 degrees, close enough will be 30. Next question I will deal with.